Welcome back to AI.Code.Cast. I see a lot of you struggling with a classic problem, the container with most water problem.
Yeah, it's a favorite for interviews and coding challenges.
It is. So anyone tuning in for the first time, imagine a bunch of vertical lines, like bars on a chart. Each one has a different height, right?
Right.
And the challenge is you got to pick two of these lines and think of them as the sides of a container.
Exactly, like walls.
Walls. Perfect.
Yeah.
And we want to figure out which two lines would make a container that holds the most water.
Key point. It's not just about finding the tallest lines, it's that space between them too.
Right. The width matters. That's like the base of our container. And of course, the shorter line limits how high the water can go.
Like, if you're building a pool, the lowest wall dictates how much you can fill it.
Exactly. Now, I bet a lot of people hearing this think, okay, let's just check every pair of lines. Calculate the area for each one. The brute force method.
Simple, right? But here's the catch. As the number of lines grows, that gets slow. Really slow.
Like, imagine 1,000 lines.
You're talking tons of calculations, not practical.
So there's got to be a better way, right?
Here is. And that's where this idea of two pointers comes in.
2 pointers. Okay. Lay it on me.
Think of it like two scouts, right, exploring these lines.
Scouts. Okay, I like that.
One starts at the very beginning, the other at the very end. Widest container possible.
Right. Maximizing the width to start. Makes sense. But how do we know if it's the best container?
Well, we got to calculate the area, right? Width's easy. It's the distance between the scouts. Height. That's where it gets interesting.
It's the shorter of the two lines, yeah. Like the scout standing next to the shorter bar, that's our limit.
You got it. So we find that area. Now we got to move a scout. Which one, though?
Not the one at the taller bar, right? Moving that one wouldn't make the area bigger because the other side's still limiting it.
Exactly. We got to move the scout at the shorter bar. Maybe there's a taller one further in, right? Could give us a bigger area.
So we're making the container narrower, but hoping to find more height to make up for it.
Bingo. And we keep track of the biggest area we find along the way.
Until scouts meet. So we go through the lines once, but in a smart way, not just checking everything.
Way more efficient. Yeah, much more efficient.
But, okay, I'm getting the idea, but how do we actually put this into code?
Yeah.
Like with actual number?
Okay, sure. Let's say our bar heights are 1, 8, 6, 2, 5, 4, 8, 3, 7.
Got it.
Our left scout, they're at index 0, height is 1. Right scout's at index 8, height 7.
So which is 8, right? 8 minus 0.
Yep.
And area's 1 times 8, so 8.
First area, 8. Now, gotta move a scout.
Left one right. Shorter bar.
You got it. Moves to index 1, height's 8 now.
Okay, so width is 7.
7. Shorter height is 7 now.
49 for the area.
C, much better already. Max area is 49 now.
Okay, what's next?
Right, scout's turn. Shorter bar now. Moves into index 7, height 3.
Width is 6. Shorter height. 3. 8.
Doesn't beat our max. We keep going, always moving that scout at the shorter bar until they bump into each other.
So we're going through the array, but not in a dumb way. We're being picky about which moves we make.
Exactly, and that's why this is so much faster. Brute force, remember, that was O of n squared.
Yeah, the more lines we get, the worse it gets.
2 pointers, this is O of n, way better.
So like 1,000 lines, 1,000 operations, not 500,000. That's amazing.
And space complexity, still O of 1. We're not using up extra memory no matter how big our input gets.
2 pointers, it's faster, less memory. Kind of more elegant, too. Right?
Way more elegant. And here's the cool part. It's not just for this problem. You'll see this pattern in tons of coding challenges.
Really? Like what?
Finding pairs that add up to something. Merging sorted arrays. It's everywhere.
So learning this, it's like a superpower for coders, huh?
Totally a superpower.
Okay, one last thing. Any way to make this even faster?
Yeah.
Can we stop early sometimes?
Good question. Yeah, there's this idea called early exit.
Early exit?
Think about it. As our scouts move closer, there might be a point where even if the rest of the bars were super tall, it wouldn't matter. We wouldn't beat our best area.
Because the width got too small, yeah. Even with max height, it wouldn't be enough.
Exactly. We can just stop there. No point in checking the rest. Saves us even more time.
That's awesome. Like we're being smart about it every step of the way.
It's all about those little optimizations, right? Make the code smarter.
This whole container with most water thing, it's been awesome. Started with brute force, then these super smart 2-pointers. Even an early exit trick.
It shows you, right? Like taking your time to really think about a problem pays off big time.
Totally. Okay, gotta leave our listeners with a brain teaser.
Yeah.
What if, instead of biggest container, we wanted the smallest?
Ooh, good one. Makes you think about it differently, doesn't it?
Right. Would two pointers still work the same way? Starting wide, moving the shorter one, or
Yeah.
something else?
Something to think about, huh? Even a little tweak to the problem changes the whole game.
Well, that's all the time we have for this deep dive on AI.Code.Cast. Big thanks to you. You've been amazing explaining all this.
Happy to be here. Love talking about these clever solutions.
And to everyone listening, keep practicing, keep those brains sharp. We'll catch you in the next episode of AI.Code.Cast.